GATE 2017 Civil Engineering Set 2 Question 11. For a broad gauge railway track on a horizontal curve of radius r in meter, the equilibrium cant E required for a train moving at a speed of v in km per hour is. The four options given are A. E equals 1.676 v square by r, B. E equals 1.315 v square by r, C. E equals 0.8 v square by r, and D. E equals 0.6 v square by r. The relevant NPTEL reference has been mentioned. Assuming a train moving on a super elevated railway track, the weight of the train would act in the vertically downward direction, that is mg. Let us assume that the track has an inclination of theta. So the weight will have a component along the incline which will be mg sine theta. Centrifugal force will act on the train as it is moving on a curve which would be mv square by r. This angle would also be theta, and the centrifugal force in this direction would be mv square by r into cos theta. So the force along the inclined direction should be equal to 0, so that the train does not slide along the track. This would ensure that mg sine theta minus mv square by r cos theta is equal to 0. From this we would get tan theta as v square divided by rg. Tan theta can be written in another term as, where this is theta and the vertical lift that is given to the track is called the cant, and the horizontal distance would be the gauge length of the track. So we can see here that tan theta would be equal to E by G. So comparing 1 and 2, we would get E by G as v square divided by rg. This would result in the cant value E to be gv square divided by rg. So as we saw in the previous slide, the cant value is given as gv square divided by rg. So in case v is given to us in km per hour, the value of v that we would use is v by 3.6 in meter per second, as the formula is in SI units. So this would result in g v square divided by 3.6 square into the value of g, that would be 9.8 into r. So this results in the equation as gv square divided by 127 r. Substituting the value of g as 1.676 v square divided by 127 r. So 1.676 is the gauge length for a broad gauge track. This would result in 0.01319 v square divided by r. Here the value of E that would be obtained is in meters, but usually the value of E is taken in centimeter or mm. So converting this to centimeters, we would get 1.319 v square by r, where E would be in centimeters. The equilibrium cant E required for a train moving at a speed of v in km per hour is 1.315 v square over r, that is option B. The relevant NPTEL reference has been cited.